Hi, welcome back. We're going to be going over part B for number 2. It's asking us to implement skip mutatively. That is, mutate the original list so that every other element is skipped. Do not call the link constructor and do not return anything, which is kind of like a hint that we want to be doing this mutatively. And so let's take a look at the difference between non-mutatively and mutatively. So non-mutatively would basically mean that we would create a new list, right? And mutatively would mean that we would mutate or change the existing list that we have, right? And so we want to do this second thing. We want to do it mutatively, right? So I'm just going to be kind of going over how we would do this mutatively, right? And so at the bottom, I have this, let me move this up. Move it like up here maybe. Okay, cool. And so we have our list A, right? And list is just our variable that we're going to be keeping track of. You can see up here, right, that list is going to be updated like as we iterate through the linked list. So in this case, what we basically want to do, right, is we want to skip every other value, right? So we would want to skip this, and we want to skip this. So this is pretty easy to do, I guess, if you draw like a picture, which is kind of like at least I understand it a lot better when I drew a picture. And so basically what we want to do is we want to reassign this pointer over to point to the like the next link, I guess. That's how like we'll skip over this second link. In other words, what we want to do is we want to reassign this pointer to point to the third link. And so we know how to access this, right? This is list.rest, and we know how to access this, which is just list.rest.rest. And so kind of like, without even like starting to like write any lines of code, we can kind of just say that, hey, we want to be reassigning list.rest equal to list.rest.rest, right? So that we can have that pointer that goes over here. And so in that case, and draw this back, this pointer would get reassigned to this link, right? The link with 3 in it. And then what we'd want to do is we would want to increment our list, right? So that it is now pointing to our list.rest. And so what we'd want to do is we'd want to basically call it, right? But call skip on the rest of the list so that we can update our pointer here to there, right? And then we would basically just keep repeating that process until we like hit our base case. And our base case in this example would just be if list.rest, right, is link.empty, right, in this case over here. Like if we were to do the next iteration, right, if we try to assign list.rest to here, right, if we want to assign this list.rest to list.rest.rest, it would just be the link.empty value. And so we would basically just have that. And so that would be our resulting list of A. I guess it looks kind of like messy like this, but it would kind of just look like a linked list with just 2 links inside of it. Yeah, cool. So let's take a look at the skeleton. I guess we don't really have a skeleton, but let's take a look at how we would do this, how we would write this, right, in Python. So I guess like when you think about like recursion, right, every recursive like solution has to have like a base case, right? So I'll write this neater. Every recursive solution has like a base case, right? So if something, right, then we would just want to return something, right? In this special case, we know we want to return nothing because we're doing this mutatively, right? All we're doing is we're updating A, right? We're updating list A. We're not like returning list A, like a new list. We're just updating, we're mutating the existing one. And so we don't really have to touch that. And then after our base case, we know that it's, everything that doesn't satisfy our base case, right? Our recursive call and everything. And so we can kind of just copy like our pseudocode that we wrote down here. Not really pseudocode, but yeah, that's basically, whoops. Which is what we explained on here with reassigning this .rest pointer to the .rest.rest. And so after that, we'd want to call skip on the rest of the list, right? So that we can update our list pointer from here to here. Cool. So let's think about our base case, right? Kind of like our example down here with the 3, right? One thing that we want to check, right, is that, is our link.rest empty, right? Or sorry, a link.empty, right? Like this value here. So that's one thing we want to check. And there's also another special thing we do want to check. So what about the special case where we have the special case where list is actually just link.empty, right? Where's the case where we have that, right? Because that's also very possible for it to be passed in as that. And so kind of like how we do this, we can just write a simple like or statement and say like, hey, if list is link.empty, right, then we just run a return. Because there's nothing to change, right? If it's just link.empty, there's nothing to mutate. You can't really skip over nothing, right? Yeah, and so that's the solution to B. And yeah, good luck studying.